Thanks, guys. Hey. Well, I was surprised today when I saw the schedule, and just before mine was the Oleg one, right? So my talk is about JSON. He's the guy that kind of built the JSON for Postgres. Né? I was like, well, I came to his talk, and then I started, okay, I have my intro. Well, this slide and shall remove, because he's talking about. Then this one as well. And then I end up, well, at Percona, we stand for evolution, so we stand for ease of use, and we stand for freedom. So those are the stands that we have at Percona. So we are an open source company. Our products, we do open source, and we always will keep it open source. And this is how we get involved with Postgres, because we believe open source should help open source, right? And this is what we stand for at Percona. So, and we also believe that Percona and Postgres, we're better together, right? So, as I said, open source, we help open source. So, and well, we are passionate about open source. We're hiring if you want to join us. So we can go to percona.com/careers, and that's where all the slides left after Oleg's presentation. So thank you. I guess we can go for lunch, right? I think lunch is now. Yeah, but jokes aside. So our agenda today, we already saw who am I, right? So I'm gonna talk, what is this talk about? What is gonna use JSON or JSONB and why? What are the operators and indexes, how we can get them, the best of them, and optimize. And use or not use JSON, how are we gonna do with our database design, what we should do, and a little recap. So the talk should be quickie, and joke aside, I also had a lot of things in common with Oleg, so I really removed a lot of them. So we're probably gonna be really fast, and you have a lot of time for questions after the talk, or just come earlier for lunch, right? So, but what is this talk about? Before I tell what is this talk about, I want to say what this talk is not about. So we're not going to talk about internals and implementation, because the previous talk was mostly about that. So we don't need to talk about that again anymore. So we are not going to talk about JSON path. That's a new implementation, not so new anymore, but it's we can use SQL JSON inside using JSON path, but it's a huge topic. It probably deserves its own talk. So we are not going to talk about history and motivations to use or not use JSON. You're probably already using JSON, and you have your own motivation to use JSON. So the idea today is to see how the best we can use the JSON, how can we make it faster, how can we optimize, and also see some challenges. So most of the tests and results that you're gonna see here, they've done by my colleague, Matt Yankovic. So you can go for his blog post. We have a blog post at Percona. So here is the link. We can also get the presentation by the end. And we also say how we can access the data. What are the operators for the Postgres? What happens if we use different predicates? And how we can screw our select using wrong predicates when using data. I'm gonna try to do some view here. And, well, I should say here, I'm not going to do a live demo today. Usually every time that I try to do, it doesn't work. So today, I will try my best to not do a live demo, right? So then, let's start. So JSON or JSONB. When you go for Postgres, we basically have two different types, three with JSON path, but we're gonna talk about JSON and JSONB. What are the differences? So JSON is basically stored as a text inside of the database. So when we use the type JSON, we are basically storing it's just full text inside of the database, and we lose a lot of functionality, for example, indexing when you're working with JSON type. It also preserves the semantically wide space between the tokens, so it's not preprocessed when we store the JSON. So which also make it very slow when we are getting the data back. Every time that you do a select with a JSON type, it needs to process again during execution time. We're going to see later when we're talking about JSON-B, it doesn't happen to JSON-B. So if a JSON object contains duplicated keys, they're going to be stored as a duplicated as well. So the thing is, when it's is returned and the processing function returns, it's just going to use the last one that is being stored as in the JSON. So, but remember, keep in mind, it is still stored as duplicated in the JSON. And the processing functions, they will consider the last value. So those are the main different things that we have on JSON. And the main thing that we need to keep in mind here is every time that we select, we do an operation on the JSON type, a processing functions will execute again. So that's going to make things slower. And as you'll see later, we cannot use some indexes types like gin on JSON type just because it's a text. So when we go for JSON-B, we have a lot of differences. So JSON-B is stored decomposed. So it will pre-process the JSON-B and decompose to store inside of the database. So it doesn't need to be processed again when we do a select. So it's much faster. There's no repassing. It does not preserve white space. Then be careful if your application needs those. When you do a JSON-B, they're going to be lost, especially when they are parsing while we are storing the data. So it doesn't preserve the order of the object keys either. So if our application relies on the strict order of the object keys inside of the JSON, the application should not. But if it does, then we got a problem, because JSON-B doesn't keep the order. So it doesn't keep the duplicate, going to remove. So the last one is the last value of the key, going to be the one that's being stored. And it can use index much more efficiently than the JSON type. As we're going to see here, JSON-B is able to use gin indexes. So it makes things a lot faster. So there are many operators that we can use with JSON and JSON-B. So all those operators here, they work with both types, the JSON and the JSON-B. So those are operators that you can use to get the data. For example, well, I said I would not do a live demo, right? But I like to suffer. I think it's better now, right? So, for example, I have this table here. Select star from tJSON. It's a very simple table. I'm going to do a limit 5 here because I don't want all the records. I have around 10 million rows on this table. So I don't have much here. I just have the data. I have the date and the state. So the state can be available, undefined, and not available. So I can have all 3 states. I can have one of them. By the way, at least have one of them, right? So we can have some rows that has null for available or not available. And let's keep it in mind, because by the end, we're going to do some tests here, because one of the problem and one of the things that comes to the JSON is the complexity to do selects with JSON, especially when we come from the database, a relational database, right? So those operators, they are not intuitive to use. So those operators here, they are used to return the data. So I can use this one here, the tax operator, for example, just to get one of the keys. And let me see, I don't want everything. I just want this column here. So if I do this select, of course, I put in the wrong. It's not on the table. As I said, that's why I don't do live demo, right? Because it always fails. So I'm gonna get the column method, and this is all right? Here. So, as we see here, I only have one row that I have data for this okay, HMI, for this data here. So, and the state is available. So, if I want to get this column inside of the JSON, I can use this operator here. And this operator, it works both for JSON and the JSONB. So those are some operators that they're going to work for both JSON and JSONB, and they're going to return the data. So in my case, I just used this arrow operator here, and it's going to get the JSON object field by the key. So I'm using the key. We have a couple of other ones. So there are other operators, but most of the operators here, they're going to use with JSONB types. Many of the operators that works with JSONB types, they can be indexed. So, for example, the one that Oleg was using, let me just do a select here. So, what happens if I want to get all the rows that for a specific data? So I can use this operator here, this container operator. I can do a comparison on my where clause and ask him, okay, I want when my meta what, how I can do this select. So when my meta contains a JSON, right, that has this value. And in my case, is this one. Oops. So how I do solve this problem? Remember when I said one of the biggest problems for JSON is when it's not intuitive. So may I use the equals? How do I solve this problem? How I get a very specific data from my JSON here. So if we advance a little bit here, this is, oops, next one, yeah. This is how we can solve that query. See how non-intuitive a JSON select can be? If we are not familiar with the nomenclature and the operators in the JSON, we can spend a lot of time. We can just go here and try, well, the equals, they didn't work. Well, the documentation says that the meta, I need to pass a data type here. Okay, but, well, it is technically, sorry for that, a well-formed data type, right? So, but we still got an error here. So what we need to do here, look, we need to tell him that I want this is the column that I'm looking for. And I can get the available, the data here. I want all the available that was for very specific data. So this is one of the problems that we have when we get the data types here. So, and we have a lot of operators, and they will all work on the same way, or in a very similar way. So we're going to get down here for a couple of other questions that we're going to exercise. So another point that we need to keep in mind is most of those operators here, they can be indexed by a gene index. So we can improve performance. And that is one of the biggest advances when we got to use the JSON-B compared to the JSON. So those operators, they cannot be used with plain JSON. They can just be used with the JSON-B type. Keep also that in mind. So, and we also have some functions that can be used with JSON-B. For example, JSON-B pretty is one of my favorite because, you know, I like to see a JSON well format. But there are many others like JSON each, so it will return an array for all the JSON. And we can find a comprehensive list on the documentation. And again, all those functions, they're gonna work with most of them with JSON-B, not the JSON type. So here is just a small list of the operators that we can use with the JSON-B. None of those gonna work with the plain JSON type. All of them is just with the JSON-B. As I was saying, we can use gene index to improve performance when we're working with the JSON-B. We created this very simple table here. So we're storing some movies here, some movies data. One table is just JSON type. We have the column there is JSON column, so it's JSON, nanu. And the other table, we have the JSON-B column. So for the JSON type, we just create a B-tree index. Normal B-tree index indexing the text field, mostly. And for the other one, we use the gene index for the JSON-B. When we compare, like this is the explain plane for the JSON type, for the first table. If we see, it did a seq scan, right? A sequential scan. It didn't use the index, even though we had the index. And the execution time was like 3.5 seconds, 2,000 milliseconds. So that's quite a lot. If we go for the JSON-B, it was able to use the index that we created. And the execution time for the very same select with the JSON-B, it was 700 milliseconds. That's quite a lot, right? Like 3 or 4. Yeah, my math is not good, but around 3 times, 3 points. And one thing that we saw, we realized it is, as the more complex are the JSON documents, the huge is the difference between the JSON and the JSON-B performance. So those are very simple JSON. We don't have too many complex. But we did sometimes that we got like 10, 15 times more performance using the JSON-B type than the JSON type for the same data, the very same data. So then keep in mind. As I was saying, those some simple tests. We run like a few times, more than 100 times, and just to make sure they were consistent. So those, we got here the average time and the mean and the max time. As we see, the performance for JSON-B is way better than the performance for the JSON types. So what we get here, you're probably gonna prefer JSON-B over JSON for most of your applications, right? Because so the performance is much better. Well, then why we still have JSON there though? So mostly for compatibility, there's a lot of applications that they still use JSON type, and there's some few very use cases that, yeah, it's good to use, you can use JSON, that you can still have good performance. Well, it's not everything flowers, right? The flowers, usually they have some things. And we have a problem when it goes to JSON, and especially JSON-B. Writes. Writes are a problem. So insert and updates, as Oleg showed here, they are a huge problem when it comes to JSON. So we got a huge performance degradation in our tests. We tried to do some optimization. We tried to do something. We got some improvement, but the performance for writes is still much better when we are not using JSON types inside of the database. And mostly because, well, the hot updates, usually as we are updating a huge data, usually do not get hot updates as we do for OLTP normal tables. And the toast as well. So if we have large JSONs, toast gonna be a problem that for us, and not only for insert, also select performance is gonna have a lot of degradation when we have a large JSON objects. And that was very clear to see on the Oleg's presentation, and he was showing those graphs. So we could see when we went to the writes, the degradation was really huge. And one thing that we need to be very careful is the type conversions can ruin the day. What I mean about type conversions? So remember, the JSON itself, it doesn't have a strong typing. So we can store anything inside a JSON, right? Everything can be stored inside a JSON, even binary data. So if we're using an index and we are using the wrong type, the database can just decide, okay, it's the wrong type for this index and this operator. I'm not going to use this index. And we're going to see an example just shown here. So we need to be very careful that we do not make any assumptions of the type that we have inside of our JSON, because this can really ruin the day, and we can get a huge performance problem. And can also get a lot of errors and odd results. And for example, we may have some integer inside of the JSON, and we are just ordering. And as it has no strong type in the database, might think it is a string, and does a string ordering, right? So then we might get the 1 million before the 9, because just string comparison, right, in the ordering side. So be careful to do not make those assumptions of the types inside of the JSON. If you do need strong typing, make sure you're typecasting them. Okay, that said, remember that table that I just showed you. So that's a very simple table. We have an ID, it's just an integer, and we have a meta column. The name of the column is meta, it's not a meta column. The name, horrible naming, right? But yeah, it is what it is. So, and this table has JSON inside, so it's a JSON B type. So I indexed that table. I just create a gene index using the default operator for the gene type. And this is the data that we have. As I said, so we have the date, and then we have an state. So we can have up to 3 different states, right? We have available, undefined, and not available. So we can have 1, 2, or 3 dates inside of each row that can return 3, up to 3 of them. And they can have any states there. There's literally no ordering, and I just randomly inserted the date here. So with this table in mind, we want to answer 3 questions. 3 simple questions. So how I get the entries that have a very particular state for a given date? And this is an example. For example, I have this date, 2021, January the 1st, and I want the state equals available. Well, if I just type this guy, sorry, I'm lazy and I usually type wrongly. I'm going to copy and paste, right? So if I just copy here and paste, what I get is, well, yeah, I'm going to get an error. Because, well, that's not the right operator. That's not the right way to do. Even though it looks quite nice, quite JSON-ish, right? It's not right. So, but it's a good example how to, what I want to do here. And another one is the same question as above, but instead the state is one of many. So I want either available or whatever other state. How I do this select here? So, and the last question is, does the entry that include this date exist? Is it not new? I want to have a non-null select inside of my JSON. Are those possible to be answered? Well, in plain SQL, that would be pretty simple, right? So select where that column is not null, that's going to return. So this is going to show us some of the complications when we're working with the JSON. It's not the JSON itself, but how to work with the JSON. So let's try to answer that. And the answer for my first question is this one. And let's see if that works. It looks fancy, right? So let's see if it works. Look, well, it does. It surprisingly does, right? But if we look at the syntax, that's pretty weird, right? It's not something that I would come up to my mind, how to do a select this way. But yeah, it does. So I can use the operator and just send a JSON inside here because this operator is waiting for a JSON here, right? Well, we can use this notation here that looks also a lot JSON-ish. Okay, not this one, but this one here. But one thing that we need to keep in mind, remember that what I say, we should not make assumption of the type. Look, I'm trying to compare. I'm just telling this guy, look, I want everything from this date that the data want. I want to get the state, and the state should be available. Well, I'm assuming this will return a JSON type for me, and so I'm just parsing this to send a JSON type. Well, it gave me the result. But look, it took a lot more time. If we compare without an explain, I'm going to do an explain just right now. So this is the first one. It immediately comes with the result. The second one, oops, not this one. The second one, we need to wait a little bit, right? If we do an explain, explain, I like verbose, and I like buffers, and analyze. So if I do an explain of this query, what we see here is it didn't use the index. The index was just ignored because I made a wrong assumption that the data type from the left side of the operator was the same data type on the right side of the operator. So the operands, there is a mismatch with the data types. If we do the same explain, I'll just copy here because I'm lazy, right? But instead of this query, it's this one. And here we do an index scan. That's why it's so much faster. We're just doing an index scan here, and this is the condition for the index that we're using, right? And this is where we really need to be careful to do not, again, not make the wrong assumptions for the type that we're using here. So if you keep moving, let's just go to the next slide. So the next question is the same question as above, but instead of just get one of the states, I want to get more than one of the states. And again, we come with something that's really unnatural to those that works with SQL. Let's put on this way. Oops, not this. And this is the syntax. yeah, it brings only like what we wanted for. I was querying for available and not available. So I'm gonna get everything that has either available or not available, or both, right? It's an or operation. So any of those, I need to, in this way, there are other ways to answer the same question. Let's make it clear. This is not the only way that we can answer the same question with different ways and alternatives, but it's not natural when we compare for SQL, the pure SQL. So, but yeah, we can do. And as we can see here, so it's using my index. I'm gonna do just a normal explain here. Just to make sure, yeah, it's doing an index scan. So it's still using my indexes. And the last one that might be the most complicated one, at least when I was trying to write those slides, it took me really a long time to figure out this query. So I want to do a select where the column is not null. So that is a very simple question for a database to answer, and should be like, well, actually, the syntax is pretty simple. But I tried many approaches until I really got to this one, because, well, the other ones were pretty complex, right? So then we always go to the complex approach and try to do things. And then it comes to that this is the one that I got. So this is one of the simplest way to answer the question, like, I want everything that is from 2021, June 27, and so that I have this column there. This is present, this is not new. The major difference here is all the other queries, we are looking for the values of the column. And this one, we're looking at the column itself. So remember, this 2021 inside of my JSON is the key, not the value of the key. Now we are looking for the key inside of the JSON. And that was the whole complication. So if it was just to look for the value, that like whatever thing we get that's not new, or that doesn't exist, we could just do a negation of this any here, right? We can negate the any, and those values here, they won't be present. But now I want to parse and look inside of my keys to see that that key is present. I want that key present in my result. That was my major complication when I came to this select here. So those are examples to show how it can get complicated when we're working with JSON, right? And now, to JSON or not to JSON? Shall we use or not shall we use JSON? Well, those are just some advice. As being shown here, JSON is already being used a lot, and it can make life a lot easier. Definitely can make life a lot easier. But we should not just dump the JSON inside of the database. And that's a problem for most of the developers, because they do not design. They just think the JSON is a replacement for the database, and they put everything inside of the JSON just to replace the database. The JSON still needs design. We still need to be careful when we are designing our JSON for what we are putting there. And I've seen a lot of applications being just broken and stop working because on the version 1 the application, they created the JSON with that assumption that was one column inside of that JSON, and the version 2, there was another development team, and then they forgot about that column, and they just stopped using that column, the JSON, the application stopped work. The database won't do the validation for you, but it's still database design, you know. That's a very important piece of information that people, they usually forget and mistake. Another thing that people also think it's Two, that's gonna make things faster is just use a JSON inside of your table. You create a table with one JSON, everything is fine. I've worked as a consultant to a company in China. They were migrating their application for Oracle to Postgres, and they were using JSON inside of a Postgres. Well, they were using JSONB, that was fine. And the thing is, they were using B3 indexes on the JSON type. The problem was not the B3 indexes. The problem was they were indexing the keys inside of the JSON. On the very same table, they had 7 columns and 128 indexes. And they didn't know why that was really slow, you know? When they were inserting and updating data, the database was just like slowing down. Well, it's still database design, right? So those are the things that we've seen a lot when it comes to work with the JSON. And the problem is not the JSON itself. The problem is the mindset that comes with a lot of the developers when working with the JSON. And then they just blame your database. Look, your Postgres doesn't work well with JSON. See? It was working pretty well when it was with the old database. But now when it comes to Postgres, well, we have a lot of performance degradation. I don't know why, right? We need to do some investigation. But those are the problems. And one thing that we found is sometimes it's very convenient when we use generated columns, for example, to extract some data from the JSON, and you just need to index just that very specific columns of data so you can get it indexed in your table. So the mix of them can be very convenient, can speed up a lot the application, and can make life a lot easier, especially when you have some complex queries that your developer just said, look, I need to answer this question, I didn't get how to do it in your database. Can you please write the SQL for me? Yeah. It can make life a lot easier. And so we did some tests when using just JSON or when using a mixed design. We got a lot surprised that for the mixed design and for some loads, keep in mind this is a very load specific for the data that we had. Your load, your data set might have different results, and that's why it's super important to test them, right? So we got surprised because the mixed load and with some plain old school tables, in some cases, we got a lot faster than using JSON. Of course, for some cases, the index, especially the gene index, helped a lot. It improves a lot of the performance. But still, having the mixed gave us the best of the both. So having a mixed design with some JSON and some plain old tables gave us a lot of the best result. Here we used the move tables. Again, we repeated the test like 100 few times just to make sure. We collect all the minimum max and we did some average. So did some math to make sure that the data was accurate. And now we come to recap. So using JSONB is definitely the way to go, right? For most of the applications, you won't use JSON type. You're gonna use the JSONB. So be careful of the type conversion. I know I've been saying that like all the way along the presentation today, but that was one of the most problems I've got during like working with the developers on database. Mistaking those conversions got a lot of troubles. So use the available indexes, especially gene indexes for JSONB and all these types. It's gonna give you a lot of benefits and improvements. So the more straightforward the JSON, the simpler the JSON, the best. Don't try to make super complicated JSON unless you really need to. I've seen some JSONs that they have a lot of inference, and then you see a JSON inside of the JSON inside of the JSON, and then in the end we had like 100 objects, one inside of the another. So it's give a lot of stress to the database, especially when you are inserting or updating, because it needs to be parsed. Remember, every time that we insert a JSON-B, it needs to be parsed. The database needs to make sure that the document is consistent and applies all the rules. Yeah, nested JSON is the same as the above. So it can cause a lot of problems, especially with functions. So I got, like, for example, the JSON-B to record set function. That was a very simple way to get the data from the JSON. But when we had a lot of nested JSON, I got a lot of weird problems. So be careful with that. JSON data which format change. So as I said, removing and adding keys or elements inside of the JSON, that's very dangerous because the database won't tell you that that specific JSON doesn't have that key that your application needs. So be careful because you can just crash your application and the database will just be there, standing by. So, and JSON just dumped inside of the database, it won't scale well in Postgres. We still need a lot of design. Database design still matters even using JSON. I think that's the key that we should take from here. So database design still matters. And thank you, guys. That is this. So yeah, we're hiring. And questions? I guess we still have a couple of minutes.
Okay, I took off the mask so I'd speak clear. Okay, Charlie,
Yep.
you got me thinking. This is what if, okay? This is...
Sure.
Okay.
Sure.
All right. First part, it's going to be 3 parts. Part 1, index with the include option. Part 2, parsing out a JSON and just creating a column explicitly, ordinary traditional, and you put the index against that. Mm-hmm. And part 3, using something like Citus that shards a table across multiple nodes, making it a little easier to do inserts or updates because you're sharing it across loads. Okay, those are the 3 comments. Go ahead.
All right. So the first one, index.
Include option.
Okay. Index include options. So you mean the gene type opt index? Can you elaborate a bit more?
Create an index, include, and then you use non-key parameters associated with when you create the index.
Okay. Well, that definitely gonna add a lot more load, especially when you have writes, right? Because so it needs to be preprocessed again. For some cases, it might help you with reads because with a read have the function inside of that index. So, but that might be a very specific case. For the majority of the case, I personally would not suggest unless I had, like, I know the loads, I can do the test inside of the loads, especially because the writes pressure that you're gonna put, it might not worth the performance gain that you have for the reads. The second one?
The second one, you pull out the value that you're going to query on from the JSON and create your own index, or column index, traditional.
Mm-hmm. Yeah, we tested that with generated columns, right? So generated columns are amazing for that. The problem is because they are not updatable. So, but we tested that. We tested around 5 different case scenarios with generated columns. In the majority of them, we got a lot of improvement. But it also depends on the data type, on the size of the data type that you're pulling from the JSON for that. And it's also going to add a lot of the load on the writes. So all those options that we have, you are adding loads to your writes because you need to put more. And you need to be careful if you have toast. If the data you're pulling from your JSON, if they're too large, then not only the JSON go to the toast, they also go to the tools. And then you lose twice because now you don't have hot updates anymore, right? But yeah, we got some performance improvement for reads from the 5 different loads that we had. In 4 of them, we got really good performance loads, and they were better than just using, in most of the case, the gene index inside of the JSON. But it's load specific.
And part 3 was using a technology, because right now I'm looking into Citus, and it's kind of really cool. And I remember the demo documentation. While you were talking, it occurred to me, Citus, when they, on their GitHub, they actually use JSON as an example, but they never explained why they were using JSON. But it's an excellent use case.
Yeah, I'm not knowledgeable at site at all, so I'm probably not the best one to answer that question. But I definitely would be very curious, you know, to do some tests and see the results, because yeah, that would be a very interesting test case to do, and to see how they split with those different nodes. But yeah, I definitely not the best one to answer that one for you. The
Okay.
fourth one.
No, that's I'm just filling in. I'm going to write a blog on Citus, and you just gave me the idea of, oh, okay,
right, cool.
I'll use some of the benchmarking tools to populate, and we'll see what it does.
I would be very interested in see the blog post, definitely. Okay, more questions?
So let's say you have more than one JSONB column on a table.
Okay.
Do you have any thoughts on whether you should use separate indexes, indexes, or one multi-column gen index?
Well, that's also very load specific, but most of the case would recommend you to use separate gene indexes. The gene indexes, you have 2 operators inside of the gene index, the JSON path and the other one I don't remember. The JSON path is the default that we just used here. So how does it work? It will create an entry for every key and value that you have inside of the JSON, right? So the other one that I don't remember the name now, it creates a hash. It gets the key, the value, it gets the row, and just create a hash. So it's usually a lot faster when we are doing comparison, like I have this key and I want just equals the value because it's a hash, right? It's a lot faster, but it doesn't work with all the operators. Maybe you can get a lot of performance if you use this and combine those two on those 2 columns. But that was to test. If you just use the default one, I would suggest create 2 different indexes, and that's will probably be faster, because when it will carry the index in the end, the index, even though it's an inverted index, you still have a tree, right? So the tree going to be still smaller for each of them, probably. So then still be faster for select. Okay, thanks guys. It was a pleasure. I hope that was useful. Thank you again.